Today we are going to carry on with the last topic on the Mapwork, and before we start going with the other part, I first want to look at what we covered last time, and that was on the introduction to the World Cup. So my names are Stephen Onyango Okuta, and I'll be taking you through geography on the foundation part, especially on the map work. So last time we identified what a map is, and we defined map as a representation of the part or the whole area of the Earth's surface. And we went further and differentiated it with a map, with a plan and a picture, whereby we say that a plan is an outline of something or of a structure that is drawn to a scale. And also we say that a picture is different from a map because a picture is the representation of the real image. So differentiate the three: a map, representation of a part or the whole part of the earth. Then we have a plan, which is an outline of something that is drawn to scale. Then the last one is a picture, which is the representation of the real image. So after identifying that, we went further and looked at the types of the maps, whereby we named the topographical maps, the atlas maps, and the sketch maps. And we said that the topographical maps, these are detailed maps that gives the representation of the physical features found within the earth. And again, we said that a sketch map, these are maps that are not drawn to scale, rather they are used to define certain purposes that are meant to be done, and therefore they are used maybe to give the specific instructions for those people who want to use them. Then we said an atlas map is a combination of maps combined together to form a booklet, and this is what we call an atlas map, which has different types of maps that contains the relief maps, the development maps, the land formation maps, and so on and so forth. So differentiate those. And then apart from that, we also looked at the scales, and we identified what a scale is. And when we say that these are measurements that are given to present the actual representation of the measurement or of an area. So we identified that there are three types of scales, which is the large scale that are used to draw small areas like a village. We gave an example of a village. And then the second one was the medium, which represent the regional presentation of the drawing. And then the last one was the small scale, which gives the larger area, the view of the larger area that has less information, because it tries to cover a larger area, and therefore structures or meaningful information cannot easily be obtained. Rather, it gives an overview of what should be done. And then apart from that, we also looked at how these scales are used and how they perform. And then we say the scales are used in terms of drawing to draw an area and reduce it to a paper form. And again, it helps us to estimate the length, or we can say the distance of point 1 to point 2, or from point A to point B. Then again, scales are also used to show the actual area that a place occupies. And then we left by seeing how we can use different methods on how to calculate distances from point 1 to point 2. So we had started with an example of using a string, and then within the string we said once you have a drawing, and within this drawing you want to use a string, what you need is you need the map, and that is, let's say you have a place like this. You have a place, let's say you have a place that you want to use in terms of estimating the distance. So let's say you want to estimate point A to point B. So when you want to use to estimate a point from point A, say to point B, and you have your line like that, you want to know the distance. So what you need to do is, if this is your string, you just have to stretch it from here, and then you take it straight to where your B is, to point B. Then mark the points, mark where B ends and where A starts. Then take it down to your linear scale that has been provided down there, which has numbers. So you'll have to measure this string, and then it will give you the actual distance of what you should do. So it's very, very important to know that when measuring point A to B using a string, you have to mark the starting point and the end point. So that is very, very important, and that is used within the scales. And then we went further and explained why these scales are used. The scales are used to express the actual position of the place. So it's very, very important to note that whenever you want to use a scale, you have to know which units are you using, especially when dealing with places of unknown distance, of unknown length. So it's very, very important to know that. Now, for us to do this, we say that scales are presented in different forms. So there's one, we say the statement scales, which uses the words. You express the scales in terms of words. And then the second one was the representative fraction, where you use fractions to represent. And when that's when we said you use numbers, but you use the word denotation too, which is one. We said, for example, we said that the large scales uses between 1 to 100,000, 1 to 100,000. So, and this is how we say we present it, 1 to 1,000. When you're dealing with 1 to 100,000, this is 1, then the notion of 2, and then you say 1,000. So 1 represent 1,000. So when you use that type of scale is known as, this type of scale is known as the representative fraction, RF. And then the other one, we said, instead of writing this into the representative fraction, you can change it into the statements fraction, in which you require to write it in words. You said 1 represent 1,000, 1 represent 1,000. And then this is the actual scale that can now be used to calculate the differences. And on the screen, you can see that we can say 1 kilometer equals to 100,000 kilometers. So if you want to get a solution to this, then we say we take 60 kilometers, which equals to x, and the presentation will actually be that 60 multiplied by 100,000, and this will give you to around 6 million. Therefore, R scales can be R scale or RF can be written as 1 equals to the 6 million representation of the actual distance that we need to know. Then, looking at this, we said that scales help us to calculate the area of the map. It helps us to calculate the distance. It also shows us the relationship between the map and the actual distance. So it's very, very important you know that scales can be used to estimate all this before we go to that. Now, the other part that I now want us to look at is how these scales, how scales in the maps can be used to calculate the area and the distance. So how do we use this? So last time we used the string, and now we want to look at the other form, which is the number 2 one, is what you call a pair of a divider. So all these measurements are noted under one term, and that is the quantitative representation of the information found in the map. So it's very, very important you know that whenever you are dealing with the numbers, you deal with what we call the quantitative kind of information, of the quantitative data. But when you're dealing with words, that is the qualitative type of information. So for us, because we now want to deal with numbers, we'll now take it to the quantitative, and that's why we say the measurement, and then we look at the area. So when looking at the measuring the distance, we've already shown how we can use the string, where you measure from point 1 to point 2, or point A to point B, and that has given us the leeway of doing it. Then the second one we should look at is a pair of divider. So in a pair of divider, all of you, when you join Form 1, you are normally told to report with a set. With this set, there's a pair of divider. So a divider is something that looks like this. It looks like this, the one drawn on the screen, and then it is flexible because it has a lever here that helps it to rotate, and you can put or you can measure an extent that you want. If you want to stretch it there or stretch it there, it can all give you the measurement. So once you've measured, let's say this is another point A and this is point B. You want to measure from point A to point B using a pair of divider. You take these measurements the way it is without interfering with the lever there, and then you transfer it to what we call the linear scale down there of your map. So the linear scales as numbering, that's 2, 3, 4. Then you pick your pair of divider. If it is here, then you measure from the starting point, which is point 1, if it stretches up to point 3, and that will be the distance that you are given. So it is this distance that you use the scale that you've been given to convert it to the actual distance of a place that you have been given. And I've told you how to calculate the distance and how to convert it, because you'll have to know that how if you're using centimeters, how many centimeters can be equal to a kilometer? How many meters can be equal to a kilometer? So it's very, very important to note this. So we can use a pair of divider, and it's an easy one you can draw, but this uses what we call the straight lines. It's very, very important you know that a pair of dividers applies to areas that are straight. So if you have a place, for example, let's say you have this is another line. This is your line which has meanders. You see it has meanders. So if you are using a pair of divider, this is point A, then that is point B, then it has meanders. So make sure you estimate the straight places first. Note them. You can mark them like that. You mark straight places. Then it is these straight places that you transfer to your linear scale. You transfer to your linear scale. After transferring to your linear scale, you add the figures. If point A, if it was point A to point B equals to 6, you put it aside. Then point B to point C equals to 7, you put it like that. Then point C to point D, again put it like that. Put it like they say there is 5, there is 3. Then you add them all. So you add point A to point B plus point B to point C plus point C to point D. then this will give you what you call 6 plus 7, which is 13, plus 3, which is equals to 16. So it is this 16 that you convert to the actual figure. Then the last one is the use of this one, a piece of a strip paper. So normally if you want to use a piece of paper, make sure that it is in a straight line. And to show that if this was my paper, and I want to use it to measure from point 1 to point 2, then you mark the straight paths, and then mark the first point that you start with, then measure it to a figure that you have been given or a path that you've been given, then mark them the straight line. So it is this that you transfer again to the linear scale for you to know the actual distance. You still transfer it to what? The linear scale. So that is very, very important for you. So for example, on your screen, I've given you one example. If a railway distance from station A to B was 20 centimeter, then you're told to find the actual ground distance in a kilometer. If the scale was used to construct a map, and the scale of the map that you've been given is 1 to 50,000. So we know very well that 100,000 centimeter equals to 1 kilometer. So what we say is that if a scale of 1 to 50,000 has been given, then you say 100,000 equals to 1 kilometer. So what you do is that you take a kilometer, then you multiply. You take a kilometer, then here, then you multiply by 50 centimeter, which gives you half a kilometer. So it is this half a kilometer that you convert it. Once you convert, then you realize that 20 centimeter gives you what you call 10 kilometer. So 10 kilometer is the actual ground distance, or actually it is the length of the railway. So it is this 20 centimeter which represent 10 kilometer once it is converted. So if you are running from point A to point B in that railway station, what you do is that you are running at a distance of 10 kilometer, which is represented by 20 centimeter. So make sure that that is very, very important for you to know when dealing with scales. Now, this brings us to another area, which is the calculating the area of a map. How do you calculate an area of a map? How do you know that this is the actual distance or the actual area of our school? How do we do this? Because our school has just been reduced to a small paper. So how do we calculate and know that this is the actual school of ours? Somebody may say, our school is too small because it is on a paper, or it has been drawn in a book. It is like that because this kind of papers, or if you're even dealing with a plan, they are reduced to a scale. But in real sense, they represent the actual area or the actual distance of a place. So don't ever say that our school is small because it has been drawn on a small piece of paper. No, it is the scale that has been used to reduce it. And remember, we said you can use the large scale if you want to know so many things, or you want to study a lot of things that have been studied in an area. You use the large scale because this gives us a bigger view of what we want to see. If in terms of the infrastructure, we'll see these are the road networks. If it is in terms of the schools or the structure or development, we'll know that it is here and here and here. And that's why we say the large scale are normally used at a village level. It's not necessarily a village, but it's a small area, just to present a small area. And then when we are not interested, but you want to do the overview of the area, we'll use the small scale. These small scales, the small scale will cover a bigger area, but with less visibilities of the material. So we'll only have a general view of how the area looks like. So calculating an area of a map and or an area of a place. So there are different methods that are used for calculating an area, and when dealing with this, you are required to borrow from the mathematical formula in calculating the area. And the main ones that we are going to use here are the notable figures that most of you are aware of: the use of the squares, the use of the circumference, and the use of the triangles, and even the rectangles in calculating these. So number one, we can use the shapes. The shapes are the ones that I've named, the squares. You can use the triangles, the rectangles. Or to some extent, you can even use the circles, and the circles you multiply by using the mathematical formulas that are given. So that is the first thing that you are going to look at. So what is an area? In the first place, you should define what an area is. An area refers to the bigness or the smallness of an area on the Earth's surface. So whether a place is small or it is big, it represents what we call an area or a surface area. And this can be presented normally in a geographical angle, the topographical maps consideration, and the area of a place that is either regular or irregular. So there are places that are, because most places that we have are not straight as such, but they are normally irregular in terms of the shapes. So this brings us to the fundamental way of noting how these irregular places, or how the areas of these irregular places can be calculated. So note that when dealing with an area, we must know first, why are we studying the map? Why do we have the map reading? Why do we have the scale? Why do we have the contours? So be at a point that you are able to establish that this kind of a map is stated to serve these particular purposes. If you have maps that deal with with the one that deals with the development, you focus on the development. If you have one that deals with the land formations, we look at that. And if you also want the ones that helps us to define or to know the location of places, then we have to define the correct map for usage. So it's very, very important to know that. Now, dealing with shapes which are irregular, we always use what we call the squares, the triangles. We can use the squares, the triangles, and also the rectangles. And you know very well that when we are dealing with squares, the mathematical formula of finding an area when dealing with a square is side times side, or it can be length times length. Sometimes you say that this kind of a figure or a structure has equal sides. The length of each side is equal, and therefore we can even say we calculate side by side, s times s, to get the area. And then when we are dealing with the rectangle, it is length times width. It is length times width. So when you are dealing with, let's say, this is our square. This is our square. Assume that all the sides are equal. So this is side and this is side. So it is s times s. That is a square. But when you are dealing with a rectangle, where the length is longer than the width, that is our rectangle. That is our rectangle. So this is length, this is width. So the formula for it is length times width. And then we have triangle. We have triangle. So when you're calculating an area of a triangle, we always use what we call a half base times height. Is a half BH. So that is the formula for finding these figures. So this will bring us to an area whereby we want to use or we want to calculate an area of regular shape. So when you're using a regular shape, for example, when you want to calculate a football pitch, and then you say a football pitch looks like this, you want to know the area of a football pitch. We know that this side is 100 meters, then by 50 meters. So our area for that particular pitch, this is a football pitch, will be 100 times 50. That is length times width, which gives us 5,000. 5,000. And then identify which units are you using. If you are using centimeters, then it will be, for example, for this we are using meters, it will be meters squared. So that is the area of the triangle. So that is if you are dealing with an area that has regular shape. This can still apply to both the square and the triangle. But here comes when you want to deal with an area of irregular shape. For example, we are given when we are given an area like this, how do we do it? So these are areas that can sometimes they have what you call indefinite shapes, and some of them can be even an area of, let's say, a lake or a farm. It can be a mountain. So when dealing with these areas, we have to use different methods. So there are three methods that are used. One is a square method. And then there's a strip method. So when dealing with a square method, you first do what we call square methods, whereby you identify the areas. Let's say if this is our map, that goes like this. Then these are squares. That have been drawn. In your map, you'll realize that the such lines that runs from north to south and from east to west. So when dealing with squares on a map, and a map has been divided into the squares, that's what we call the grid squares. These are grid squares. So what you normally need to do is you count the number of squares. And for our case, we have here 1. You count the full squares first, which is 1, 2, 3, 4, 5, 6. So we have 6 full squares. And then we have 6 full squares. And then we have, you count the half ones. And here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we have 13 half full. Half full squares. So what you normally required, once you've calculated you have 6, in calculating an area using full and half squares, what you need to do is you calculate the number of you add the number of the half squares, then you divide by 2. you divide by 2. So when we divide 13 by 2, that equals to 7. So we have 6 and 7. You add the 2. 6 plus 7, which brings you to 13. So in these grid squares, if we say that each square equals to 1 kilometer by 1 kilometer. 1 kilometer by 1 kilometer. So it will be 1 by 1, which is 1 times 1, which is equals to 1 square kilometer. 1 square kilometer. So it is, if we know that 1 square represent 1 square kilometer, then you take this 1, you multiply by 13. You multiply this by 13, which brings you to 13 square kilometer. 13 square kilometer. That will be an area of your choice. Alternatively, you might have this kind of a map, and you've chosen to use the triangles or the rectangles. The process is the same. You fit them until the whole place is occupied. Then you calculate and you get your area. That is simple. How do we use these areas again? How do we use these mathematical formulas to calculate the areas? We use them to know the actual ground area of an estimated map. So if, for example, we are dealing with a lake, you want to calculate the area that is occupied with a lake, then we have to measure around. So for a lake, for example, it might be very difficult, but within the maps that have been drawn to scale, the lines that runs from north to south, and then from east to west. So these are the grid squares that can be used to calculate, and I've told you how you do that. So you can even replace some boxes or some squares. You replace them with other mathematical shapes. So you can say, let me use triangle. You can use triangle, or you can as well use the rectangles to calculate it. So it's very, very accurate when you use that. And again, remember, when dealing with the grid squares, you count the number of squares which are full. Then after you have counted, put them aside, the full squares. As in our case, we've counted 6 full squares. Then take the remaining squares, which are half, count them all. After counting, divide them by 2. Divide them by 2. Then that will give you to 7 full squares. Actually, it should be 7.5 full squares, right? And then when you add 6 plus 7.5 brings you 13.5. Then know the scale that has been used in each grid. If each square represents 1 kilometer, or you can say 100 meters by 100 meters, then you calculate 100 times 100, which brings you to 100 times 100, which brings you to 100,000. So it is very, very important to know that. So when you are dealing with 100 times 100, that will be 10,000. That will be 10,000. So it is this 10,000 that you convert to the right scale that has been given. So for our case, we are using meters. Here is a meter. Here is a meter. So this brings us to 100,000 meters square. So that is the actual area of that square. So take this 100 square meters, then multiply with the number of the squares that are been counted. That is after even dividing the half counted squares by 2 to give you 7.5. Then multiply by, so you multiply 13.5 times 100,000, and then it gives you the area of the actual place. Now, having looking at that, how we can calculate the distance, from point A to point B, we now want to focus on another area, which is how do we locate places on a map? How do we locate places in a map? How do we locate places in your map? Let's give this context. Maybe, let's say if you're in Mombasa and you want to travel to Nairobi, and then you'll go to a bus station or you go to an airport, or you can as well say, since I'm strong enough and my family or my forefathers used to walk from Mombasa to Nairobi, then you'll be tempted to know that by mentioning Nairobi or by mentioning Mombasa, you already know the place that you're going. And that is one method of identifying a place. We identify places by use of names. You want to go to Nairobi, you say it is Nairobi. You go to a bus stop and then tell me I want to go to Nairobi. They say pay, we'll take you there because you know the place. But if you don't know the place, it is very, very important to locate to locate you. So it's very, very difficult for somebody to locate you, because the first thing they'll ask you, where are you? Where have you reached? For example, if you are interested of meeting a person of interest, and then you've prepared yourself, you're in the house, you've prepared yourself, you say to them, today I'm waiting for my visitor to come. You see? As you wait, and the visitor doesn't know where you stay, the first thing you'll tell them is, come to such a place, or come to bus stop number 12, wait for me there, I'll pick you. Then the other person responds and comes to the place. So after coming to the place, that's when you say, have you reached bus stop number 12? Yes, you say, yes, I've reached there. Then you come. So the moment you go there and you don't find that person, we'll say that the communication has not been successful, because the person who was coming did not successfully identify stage 12. So place names are very, very important to know. Even in colleges, in school, you know that this is the staff room, you know it by name. This is where the principal sits. This is where the latrines are. This is where the field are. So we identify places by using names. So that is important. Then there's another one that is used for identifying places, that is grid reference, and we'll know how the grid references work. The third one is using bearing and compass direction. In every map that you see, you'll always see a compass drawn down there, and this is to show you a compass is normally drawn like this. This is our compass. Sometimes they can just draw and then they put N up to show where the north is. Sometimes it is drawn in full like this, and then you know where the east is, where west is, and where south is. And in the middle we know the subdivision that makes it up to 16. If it's northeast, if it is southeast, if it is southwest, okay? If you're dealing with northeast, you're dealing with southeast, southwest, and then you're dealing with northwest. So you identify this one by using the compass direction, and we'll come to explanation of how it works. And then the last one is the use of the latitudes and the longitudes. The use of the latitudes and the longitudes. So to locate a place, we use different measures or different methods in identifying these places from one point to another. And that's why we say that when we are using a place names, we identify these places by knowing the place. So, and I've given you an example, going to Nairobi or going to Nyeri, or you want to go to Northeastern, or you say, no, today I want to visit my neighbors in Somali. you already know the place. So it's upon you to identify the specific place by name, and that's how it works. Now we want to look at the second segment, the segment whereby we use the grid reference. How do we use the grid reference? So the grid reference is a network of vertical lines and horizontal lines on a map. In every map, there are these lines that have been drawn running longitudinally and latitudinally. So there are these lines, and these lines gives us the numbers. So when dealing with the grid references, there are two types of the grid references. There are 4-figure grid reference and 6-figure grid reference. So it is very important to note that the grid references are lines that have been drawn that runs from one side to another. So the lines that runs from the bottom to the top are called the northings. The lines that runs from, let's have a drawing here. This is our drawing. This is our drawing. Let's say this is our square, that we have one square, and this square has numbers. Let's say here 1, 2, 3, and then here we also have let's say 1, 2, 3. So that is our square. And we've said that these lines, generally these are just lines that run all over our map. If you have our map, they run from east to west and from north to south. So the numbers that increases from the west side to the east are called the Eastings. But the ones that increases from the bottom part, that is the southern part, to the bottom, are known as the northings. So these are the northings. So for example, if you want to identify a place, of an area using the grid reference. Let's say we want to start by using the 4-figure grid reference. So this one are normally in 2 figures. Let's say that is 11, 12, 13. Then here we have 11, 12, 13. So that is it. And we want to identify a place. Let's say these are other divisions. That is another divisions that are there. So we have the northings and the eastings that are there. So we want to identify point C. That is our point C. We want to identify it using the grid reference. So remember, the first figure you must use first. The first figure you must use, or the first connection number that you must write, is you start with what you call the Eastings. You start with what you call the Eastings. The Eastings are, I've said, these are the figures that increases from the western part, from the left to right. From left to right, the increases. So these are the Eastings. So we first start with the Eastings. So we have point C, and we have point C here. We want to identify it by using grid reference. So what you do is that you first write the Eastings, which is, if you look at this where the box starts, it correlates with 12. You first write 12, and again you look at the northings. The northings are the numbers that increases from the bottom part to the upper part. So these are the northings. Then you take the northings. Where are the northings here? You say there is 11, 12. Then we have 12 because this 12 represent this box. So you say here is also 12. And then you say the mean is up there. You write the means. So this one, the location of this place of point C you say location of point C will be equals to 12, and that is the location. So that is a 4-figure grid reference. That is a 4-figure grid reference. Now, when dealing with the 6-figure grid reference, this is the same. This is the same process, but we now include we include what we call the subdivisions within a box. Let's work another example. This one is 4-figure grid reference. Then we now want a 6-figure grid reference. Let's draw another one. This is another one here. Then we have 11, 12, 13. That's 11, 12, 13. Here again we have 11, 12, 13. These are the eastings, these are the northings. So within the mark of the measurement, that is the numbers between 11 and 12, or 11 and 12, the other divisions, we call them the divisions that have been divided into tenths. So these tenths in between 13 and 12, there are other divisions, other measurements here, call them the tenths. So within this grid reference, these ones, the small markings have numbers. Let's say if the tenths, let's say they have tenths of 1, 2, 3, 4, maybe up to 10. Here again, 1, 2, 3, 4, 5, 6, up to 10. So this is from 11 to 12, the under markings of 10. The tenths are here, the tenths are here. They cannot necessarily be tenths, can even be fifths divided into 5 parts. So let's say as we have 10. So if you have 10, you first start with the major numbers, which are the eastings. So we have, let's complete our drawing first. Those are the boxes, the main boxes. Those are the main boxes. Then within these smaller subdivisions, the tenth ones, are other boxes. These are other boxes. You pardon my drawing, it's just a sketch, and we say a sketch is something that has not been drawn to scale. So these are other divisions. Divisions are like that. Then within the northings, there are also subdivisions here like that. So let's say 1, 2, 3. They are divided like that up to the main number. So if we want to locate these places, they are again subdivided into smaller boxes, the smaller boxes of 10th. So let's say we want to identify point A. You want to identify point A there using the northing and the eastings, and applying the 6-figure grid reference. So what do we do? The only thing we can do is you identify the major. You identify the major numbers, which is the easting. So if it's point B, we can see already it is in the main box. This is the main box. That is the main box. The one that I've emphasized on is the main box that we are interested in. So we have point A here. So already we have 11 as the eastings. But we now go to the subdivisions. This subdivision, the smaller ones, where are they? We say 1, 2. We have 2 here. Then we write 2. So it is 11, 2. That is the first 3 from the Eastings. That is the Eastings. Then the Northings, we again look at this. We say the mailbox is still under 11. We say it is 11. It is 11. And where is this figure? We count 1, 2. It is 2 again. It is 2. That is the Northing. So for us to give it the 6 grid reference, you combine the Eastings and the Northings. You pick, you say the location of A will be equals to this one from the Easting, 1, 1, 2, and then 1, 1, 2. Okay, and then you put the means up. So that will give you the location of that area. So that is the 6-figure grid reference. That is the 6-figure grid reference that you can practically do at home. You can use a map to give you an estimate of what you have. So kindly you can check on your atlas maps or any topographical map that you have. Look at the linings that run from east to west, but they have figures. Normally the numbers are written in blue down there. The smaller subdivision are written in blue, and the main ones are written in black. So make sure you practice with it to know or to actually calculate the distance of point A to point B, or of point A, to know the area of that, to locate the area of that place. So location of a place is different from what you call the distance or calculating an area of a place. An area, we get the mathematics and the mathematical formulas for calculating it by using the correct formulas of either squares, triangles, or if you are using the circles, you can use the pi r square, or we normally say it is 22/7. So you can use that to calculate the area of an area by using the circumference, or even by using the 2 pi d, they half a circumference. So you can use that to calculate an area of a place. So it is very fundamental that you practice this so that you don't forget. Do it at home, and exam will be as easy as. Actually, when you're through with this, you should not be disturbed, because you shall have known that this exam is mine, and it's mine, and I will pass. So learners, make sure that these courses or these subjects are interrelated. So you borrow a lot from the mathematical part in calculating the area or the distance, and also using the units to convert from one unit to another to bring you to an exact location of what you want, an area or the distance from points of different locations. So be very careful when calculating, and make sure you use the right unit for calculation, and more so the scale that has been used by the cartographer. Cartographer is a person who draws the map. The scale that has been used to know the actual distance of the place. So it's as easy as such. Very easy. So feel good, do it with confidence, and everything shall be okay. Now let's look at the other part, the use of the compass bearing and the direction. The compass bearing and the direction. So when we are dealing with the compass, the compass, when we are dealing with the compass, it is good that we identify that this one, if this is our map or our location, let's say this is this is Kenya. Let's draw our Kenya. This is our Kenya here. You can see our neighbors are down here. This is our place. This is where the fish are. So don't worry, our map has not been drawn to scale. This is our map. We have Lake Turkana there. We have Lake Victoria. We have Kilimanjaro here. Then we have Somali. We have Tanzania this side. Tanzania, this is ocean, Indian Ocean. Then Uganda this side. So if you want to know places using the compass, the first thing, the compass bearing, the first thing we notify is that you'll always be given the compass direction of that particular area. So for example, here we'll be given that is north. So if you want to apply this and then you're told which country is on the eastern part of, by using the eastern part, you've already given the compass bearing that this place is located in the eastern part, and then you say it is Somali. Somali is located in the eastern part of Kenya. So we've already identified a place or a country by use of the compass bearing. So there are other processes that are used for drawing or connecting points. So for example, if we want to know this is at the center, this is our compass direction, and then we've been told to identify point A in our map. So what you do is that if we have our compass direction here, you can draw a straight line from the compass direction from the compass point to the area that you've been told to identify. So after that, after measuring that, you can measure the angle, the bearing of that place. You can measure the bearing of that place. On your screen, you can see for, the procedure that have been given. You've been told to draw a scale line connecting 2 points. Mark the major 4 cardinal points at the starting point with the word from. Now look at the question, ask, then provide your answer. Now this is it. The bearing direction, which are measures in degrees, it measures in degrees clockwise from north. They are written in 3 figures. The one that are measured clockwise means like this direction. That is clockwise direction are measured in what we call in 4 figures. In 4 figures, in notation of every compass direction, you are normally given the figures for the compass direction. So it is this that is used to locate the place, just as how we've used the northing and eastings. So the clockwise direction is, as you know, you at home you have you have your clock on your wall, or those who have the wristwatch. The direction at which the minute hand and the second hand, the direction it takes, that is the clockwise. So when you're measuring it, you use what you call the 3 figures in measuring the degrees. Then, how does it work? It works in 2 ways. There is forward bearing, and backward bearing. So for you to draw, to locate a place using a bearing, what you need is you should draw a line connecting 2 points, then draw the major 4 cardinal lines at the starting, and look at the question that as he has, then look at the question asked. Use what we call a protractor. A protractor looks like this. This is a protractor. Then this is 0, this is 1, 180. A complete circle makes it 360 degrees. But here we have 0 to 180. So it's normally drawn like that in your set. So when you're marking a point, let's say point A, you mark point A, and this is your compass direction. So from this point, from the point you draw a straight line like this. That is a straight line. Remember, it's not up to scale. So that is point A, and you have your protractor. What you need to do is you take your protractor, that is your protractor, you hold to the center where it is, and then around here are the degrees that are counted up to 180. Then read what kind of a degree is there. How many degrees are there from the central part to, from 0 to A. And then write, if it is 45, it is 45 degrees. So if it is 45 degrees, what you do is, we said we use what we call a 3-figure, because it is going clockwise. This one is clockwise. See, here is clockwise. We give it 0, 45 degrees. 0, 45 degrees. So that is our measurement. So it's as easy as that. And then when dealing with forward bearing, the procedure to calculate are as: you identify the 2 points, join with a straight line, draw the north direction on the second point, then measure the angle by using a protractor, then set the bearing in terms of degrees of the direction. That's what we've done. Then when dealing with backward bearing, the backward bearing, it is taken from the object. Now this is different. It is taken from the object to the observer. For example, if this is where you want to measure and the observer is here, so it is different, because when we were dealing with forward bearing, it is from the observer to the point that you want to locate. But this one is different. Now it is from the object to the observer. So when it is taken like that, it gives us what we call a mark. And on your screen you can also see how this has been calculated, whereby you've been told to, you find the forward bearing, mark the cardinal point. As I've told you, when dealing with forward bearing, you go clockwise, and the other one anti-clockwise. So, and the difference is that when dealing with forward bearing is that you mark the point from the observer's point to the place that is located, the place that you want to find out, the bearing of that place. And when dealing with the forward bearing, you deal with what we call, when dealing with forward bearing, backward bearing, you deal with what you call the observation point, that is from the observation point from the object to the observer, So it is as easy as that. You should know that whenever you are dealing with these two types of bearing, the forward bearing, that is, it is from the observer to the object, from me to you, and then you mark, you measure with the protractor. Then the other one is other way around, and we've said that when dealing with forward bearing, you go clockwise. It is clockwise. But when dealing with the backward bearing, or we call the back bearing, you count it from the anti-clockwise side. That is from the object now to the observer. From the object to the observer. So using that example, I request you at home to look at it, and this is the question that see how it has been formed, and this is it. I'll read it for you. For example, the bearing of forward bearing of I've given a town there, Tukuyu, from Kea is 050. Then the backward bearing for this will be the forward bearing plus the observers. Therefore, the backward bearing will be 2250. It will be 2250. Now, how are maps important for us? Why are they important for us? Why are the maps important for us? So, for us to use maps, actually, even when we began developing our world, even when with the coming of the colonial masters in Kenya or in Africa, they had to use a strategy. And one strategy was to identify the target. So when you identify the target, it means you must know if that target can be accessible. If it is accessible, then what are the channels? So these are the essential things that have been used to draw. That's why you even wonder, how comes did they know that they studied that they could use the monsoon winds, or the Arabs could use the monsoon winds to travel from Arabia to the eastern coast of Africa? How did they do that? It's because they knew the winds would go in a certain in such a time. The winds will be blowing towards the east coast of the East African region, and that's how they could travel using the dhows and even the ships to locate these places and go. And that's why you see many areas, many people who were explorers, they were writing down or noting down the places, placing the key points, or what we call them the mark points, where trade routes will be used or the travel routes will be used. So it's very, very important to know that map helps us to identify direction. Maps helps us to identify direction. That is another, that is one. Identify direction in that we are able to allocate a place and go to that place without even blinking, because you already know, you are sure that this is a land that is there. This place A is there. The second one is maps are used to describe features. They are used to describe features of the earth. They are used to describe features of the earth. And one beautiful thing that we can say is, on your map you can see a beautiful ocean. You can say this is a forested area. This place is good for leisure. This is a school. It gives us the structural way of accessibility, in that you are able to access and review your place of interest and your place of visit. If it is dangerous, you say, you already mark that place, it is red. This place I cannot access because the map has already shown me that this place is occupied by the wild animals which are tamed, or this place has the land processes like volcanicities. People cannot settle in the areas where volcanoes are active, or I cannot settle in this place because it is of bad weather. So a map will always give us the description of a feature. In Kenya, we know that this is a rift valley. It has been drawn on the map. This is a mountain. This is Mount Longonot. This is Lake Victoria, Nakuru, and this is the coastal region of Kenya. So it helps us to identify, understand the description of an area. And a good example we can say is tourists have been able to come to Kenya because of the description that has been given that Kenya is a beautiful land full of life. There are good wild animals, is forested. Maybe let's say Kakamega, which has thousands of bird species that are there. So this place becomes an interesting place due to the description that has been given by the map. The other one is builders maps. Builders are maps to plan the best use of the land. So those who want to construct houses, those who want to construct big structures, or those who want to develop an area, the first thing is to identify the map. And then within the identification of the map, we say that map gives the description of the place. They'll use this description and say, if this tall building is made, how stable is the land? The descriptions have been given there. Is this place swampy? If it is swampy, then maybe we need to dig it up until we reach we excavate the bitter part of the crust layer to help us stabilize the building. Or what kind of material should we use? Because those who are interested in building or developing the infrastructure can easily access and assess the usage, the durability, and also the location of the place, whether it is good. For example, you cannot build a house in an area that is prone to earthquake. We know areas, especially areas that have what you call the tectonic plates that grinds each other. These areas are prone to the earthquakes or the volcanic eruption because the underneath the earth surface is open, so they cannot build this. So map will give us, or will give the direction to what should be built there and how it should be done. The other one is the road constructors. They can also use maps to draw or construct areas. And again, we've said that areas of interest, let's say in Turkana, oil has been discovered, and the oil that was discovered needs infrastructure. It needs roads. It needs a good network to transfer the crude oil from point A to point B for refinement. So what do they need? They had to locate the place, use the map, and then say this will be the shortest route. You've heard of how they argued maybe it could go through Uganda, or it should go through Kenya. It should go through Kenya first and then goes to Tanzania, like that. So there has been this problem. So for those who are interested in making in conserving money and making enough resources and utilizing the shortest route possible to make the maximum profit, they'll always need the shortest route. And this is the shortest route that infrastructures are developed along that. So maps can be used to identify that from point A to point B is shorter. So when we mean by that, we say that if you have if you have your land is like this, that is your land. This is point A. This is point B, C, and then D. Then you want to move from point A to point D. You want to move from point A to point D. And let's say here the description of this land that has been given. So you can choose to move from point A to point B, then point D. Or you move from point A to point C, then point D. And both of these takes the longer route. So the map can give you a direction whereby you can say, instead of going from point A to point B to D, you just need to connect point A to point D by using a good road network, and that will be all, rather than using point A, point B to point D, which is the longest one. It consumes a lot and energy, time, and also resources. So that's how they are used. And the last one is maps are useful in military activities. In military activities, you've heard of our Kenyan soldiers maybe going to Somali to eradicate the militants, the Al-Shabaab militants. What do they use? They use the military maps, or the maps that have been drawn, to show them exactly where are these militants, where are they hiding, to remove them out. So this is one way in which they use, the militaries can also use this to pacify the areas that are not accessible to other people in order to do their own activities. Remember, their mission should always be in secret, and when it is in secret, it means they have to make good use of their maps to show them which routes can we use that is not known to others. If these routes can be accessible, if they can accessible, then we can reach point B without being noticed. So it is very, very important for them to identify the map, and also to help them know the right description of these areas. Then another one is the maps are used in conducting various geographical research. Researchers are interested in knowing what is it, what is new, what is developing, what is happening. For example, those that are dealing with political geography always say the boundaries that are there. Recently, we've had a problem, let's say, with Somali, around the coastal region, where they say their stretch has been taken by Kenya, and the Kenyans are saying, and the matter is still going on at the ICC. So you can use this in making reference to the studies around you, and maybe establish what is wrong with the matter. So those who are dealing with the political boundaries can say, my finding is based on this, because actually this should reach this should reach there. So it gives them a leeway of arriving to a solution to where the problem is. Others are those who are dealing, for example, those who are dealing with forest, researchers who are dealing with forest, they can demarcate and know. And in Kenya, you see, many people have been notorious in taking the public land or the forested land. So the surveyors and those who want to deal with the protection and conservation of the forest can easily go to the original map and say, this is where it reached, this is where it should start, and this is where it should stop. So those are studies that can be used also in making references and making cases for those who might think that maybe the government is doing the wrong thing, or the government is not concerned about his people. And that's why you say even the conservancies, they will want to protect their areas. And what they use the first map that has been established, that this is a protected area. So you don't have to protest against it because there's evidence of it. Others can be those who are studying, let's say, the climate change. They will want to know what is changing and how is it changing. For example, in Kenya, beginning this year, we've been having heavy rains. So maybe you are starting, there's climate change. How has it changed? So you have to demarcate this by using map and telling people that this is how it used to be and this is how it has reached. You see places, the semi-arid areas, places like in northern Kenya, have been hard hit to an extent that they have been affected. Some have fled their homes because the water level was too high. Even in places like in Nyanza, where there has been floods every year and every year. So the government can use this and come up with a map to demarcate the areas that have problems of the problems that have been faced. And it can either be drought, it can either be rains, it can ever be even those who are dealing with the locust. We don't know where the matter has reached, but the government or the organization that are responsible for it will want to get a map showing where are these locusts located, where has it reached. Right now we have COVID-19, which is affecting people. And by having a map of Kenya and then saying the highest numbers are coming from Nairobi, others are in Mombasa, and others are also spotted in other places. These things are presented in a map form that gives us the actual picture of what is happening. And we remember we say map is the actual representation of the part or the whole part of the earth. So it is important to know that. Now that the introduction part of map is over, we have looked at how map is defined. We say it's an actual representation of the earth, of the part or the whole part of the earth. We've looked at the types of the maps. The types of the maps. We have looked at the types of the maps, and more so, we have also looked at how the maps are formed, the types of the maps, how they are formed, and with their uses. So students, I'll want to stop there, and we shall continue with stage 2 of Mapwork. Take care and stay safe. Thank you.